Introduction: Amazon Web Services as idea, product, and story. Amazon Web Services is both a technology offering and a strategic idea. At its simplest, AWS is a collection of cloud services: compute, storage, databases, networking, machine learning, monitoring, and many more, delivered on demand over the internet. At a deeper level, AWS is a model for commoditizing infrastructure, enabling rapid experimentation and shifting risk and capital from users to a platform provider. For entrepreneurs, the AWS story is instructive. It shows how rethinking delivery models and economics can unlock entirely new classes of products, how relentless customer focus scales a platform, and how architectural choices become long-term strategic advantages. This training series uses AWS as a narrative scaffold for ideation. Like the Windows story under Microsoft, the AWS tale reveals patterns about platform creation, ecosystem incentives, compatibility, distribution, and governance. Across 3 parts, this guide will define AWS, explain its significance, and present 8 principles for ideation inspired by AWS. Each principle will be explained, tied to the AWS narrative, followed by common mistakes companies make and practical lessons learned. This first part frames AWS and covers the first 2 principles in depth, so teams can begin applying the ideas in training sessions. Section 1: Definition. Definition of Amazon Web Services. Amazon Web Services is a cloud platform that provides on-demand access to computing resources and higher-level services via standardized interfaces and pay-as-you-go pricing. It includes primitive building blocks, virtual machines, object storage, relational and non-relational databases, queuing and messaging, identity and access controls, composable, managed services such as analytics, machine learning, and content delivery. AWS exposes these capabilities through APIs, developer tools, and marketplaces, enabling builders to assemble scalable systems without owning the underlying physical infrastructure. Section 2: Significance. Significance of AWS for entrepreneurs. AWS changed how products are ideated, built, and scaled. Its significance for entrepreneurs can be summarized in 5 interlinked effects that influence ideation and product strategy. Platform as infrastructure. AWS turned capital-intensive infrastructure into an on-demand service. Entrepreneurs could launch without heavy upfront investment in servers or data centers, enabling faster experimentation and lower barriers to entry. Operational leverage by managing operational burdens, patching, backups, availability. AWS lets small teams focus on product differentiation rather than undifferentiated heavy lifting. Speed of iteration. On-demand resources and managed services reduce cycle time for building, testing, and deploying features, accelerating learning loops. Composability and specialization. AWS promoted a componentized approach to architecture. Teams stitch together primitives and manage services to create higher-order functionality, enabling specialization and faster feature delivery. Ecosystem and economic gravity. As more companies built on AWS, complementary businesses, consultants, tooling vendors, marketplaces emerged, making the platform more valuable and harder to replace. Section 3: How to use this story in ideation training. This series uses the AWS narrative to teach entrepreneurs how to conceive platform-aware products. The approach marries technical patterns, service primitives, APIs, automation, with commercial and organizational patterns, pricing models, developer experience, partner economics. Each principle will be explained, illustrated with episodes from AWS growth and followed by common mistakes and lessons. Like studying Windows 4 platform lessons, examining AWS uncovers how delivery model innovations reshape markets and entrepreneur thinking. Structure and scope of the 3 parts. Part 1. This document defines AWS, explains why it matters to entrepreneurs, and presents the first 2 of 8 ideation principles in depth. Parts 2 and 3 will present the remaining principles, practical exercises, prompts, and a workshop-ready toolkit to guide teams through generating and validating platform-centric product ideas. Throughout, the Windows story will be used as a comparative narrative, where Windows taught lessons about compatibility, distribution, and governance in a client-installed era. AWS teaches lessons about elasticity, service boundaries, and economics in an on-demand era. Principle 1. Productize infrastructure. Make primitives programmable and consumable. Explanation. The core idea behind AWS is turning infrastructure into product primitives that are simple to consume, automate, and integrate. A primitive is useful when it is well-defined, reliable, discoverable, and exposes a clear API. Productizing infrastructure means designing services so developers and partners treat them as building blocks, reusable, composable, and predictable. This reduces friction for teams building higher-level applications and encourages the creation of an ecosystem of adapters, libraries, and integrations. AWS exemplified this by exposing compute, storage, and networking as discrete services with stable APIs, SDKs, and tooling. The platform emphasized programmatic control, so automation and infrastructure as code became natural developer practices. How this applies to ideation. When ideating, look for the infrastructure, like functions in your domain, persistent state, identity, routing, eventing, billing, and ask whether they can be exposed as primitives. Design them so they are consumable through code, have clear performance and reliability contracts, and include developer tools and examples that surface common patterns. 3 mistakes companies make. Mistake 1. Hiding functionality behind monolithic UIs. Companies sometimes build powerful capabilities accessible only via graphical interfaces or manual processes. That limits automation and integration. Without APIs and programmatic entry points, external builders cannot compose the capability into larger systems. AWS lesson. AWS prioritized APIs and SDKs early, making automation central to its adoption. Avoid first design for capabilities that developers need to automate. Mistake 2. Offering primitives without guarantees. Exposing a primitive without clear performance, durability, and availability guarantees frustrates consumers who must build their own compensating logic. Ambiguity about limits, costs, and failure modes increases integration risk. AWS lesson. AWS invested in documented SLAs, clear performance characteristics, and usage limits. Productize not only the interface, but the contract. Mistake 3. Neglecting developer ergonomics, APIs that are inconsistent, poorly documented, or hard to use deter adoption. Engineers choose tools that minimize cognitive load. Friction at the surface level prevents deeper integration. AWS lesson. AWS built SDKs, 151 tools, and example patterns to lower the bar to first success. SDKs and reference architectures accelerate adoption. Lessons learned. Design primitives that are programmable, documented, and paired with clear operational contracts. expose consistent APIs, and provide tooling that maps to common developer workflows. Publish limits, costs, and failure modes so builders can make informed trade-offs. Episode tying to Windows under Microsoft contrast Windows early decades, where APIs were oriented toward application UI and local device drivers, with AWS API-first commoditization of infrastructure. Windows productized an application runtime. AWS productized the underlying operating and networking resources. For entrepreneurs, the lesson is complementary. Whether you build a UI platform like Windows or an infrastructure platform like AWS, the primitives you expose and the ways developers program against them determine the shape of your ecosystem. Principle 2. Make economics transparent and align incentives with builders. Explanation: AWS lowered both capital and operational cost of building, but it also made consumption visible through metered pricing. Transparent, usage-based economics align incentives. Builders pay for what they use, can experiment cheaply, and scale costs predictably as value grows. Transparent pricing also enables SaaS and services that stitch AWS primitives together with measurable economics. Designing incentive alignment means crafting pricing, credits, partner programs, and support structures that reduce initial friction for builders while preserving sustainable revenue for the platform. It also means offering predictable cost controls and observability, so customers can manage spend as they scale. How this applies to ideation. When ideating, consider how your pricing and commercial model affects builder behavior. Can you enable low-friction experimentation? Do you provide predictable scaling paths? How will partners share revenue or be rewarded for driving adoption? Make pricing explicit and design mechanisms to mitigate unexpected costs for early users. 3 mistakes companies make. Mistake 1. Opaque or complex pricing that jitters experimentation. Complex pricing or surprise bills discourage usage. Early-stage builders need to forecast costs to validate business cases. Opaque models create uncertainty and slow adoption. AWS lesson. AWS published pricing calculators, free tiers, and cost management tools to lower uncertainty. Clear pricing accelerates trials and pilots. Mistake 2. Charging before value is proven. Platforms that monetize too aggressively at the earliest stages can block adoption. Builders often require runway to iterate before producing revenue-generating products. AWS lesson. AWS offered free tiers, trial credits, and startup programs. These reduced early cost barriers and encouraged experimentation. Mistake 3. Misaligning partner incentives. If partner programs reward volume over quality, or if platform economics extract excessive margin, partners may build elsewhere or prioritize portability over deep integration. AWS lesson. At AWS evolve partner and marketplace models to balance revenue share, co-selling, and technical enablement. Align incentives to reward long-term mutual success. Lessons learned. Make pricing transparent, predictable, and tied to value creation. Offer low-friction entry points, free tiers, credits, or pilot programs for experimentation. Design partner economics that reward genuine value creation, not just volume. Episode tying to Windows under Microsoft Windows historically used licensing and OEM bundling as dominant commercial mechanisms, which created predictability for hardware partners, but also complex contractual dynamics. AWS changed the calculus by turning cost into a usage meter and by offering programs that subsidized early experimentation. For entrepreneurs, the juxtaposition suggests deliberate commercial design matters. Whether you bundle licenses like Windows or meter usage like AWS, align economics to the behaviors you want to encourage. Closing for Part 1. This first part introduced Amazon Web Services as a platform and strategic idea for entrepreneurs, explained its significance, and unpacked the first 2 of 8 ideation principles. Productize infrastructure and make economics transparent. Each principle included practical guidance, common mistakes, and lessons grounded in the AWS story and contrasted with Windows-era patterns to enrich learning. In Part 2, you will receive the next 3 principles. Principles 3, 4, and 5, each unpacked with practical examples, mistakes companies commonly make, and lessons learned. The narrative will continue to weave the AWS story with the Windows story so entrepreneurs can see how different platform eras solve similar tensions with different levers. If you prefer a different ordering or to cover a specific principle next, tell me which one, and I will prioritize it. Part 2 Introduction. This part continues the AWS-based training story, presenting the next 3 ideation principles inspired by Amazon Web Services. Each principle is explained, illustrated with how AWS applied the idea, followed by 3 common mistakes companies make and practical lessons learned. Where useful, the narrative contrasts AWS-era choices with earlier Windows-era trade-offs, so entrepreneurs can see how different platform eras use different levers to solve similar problems. Principle 3. Automate everything and enable infrastructure as code. Explanation. Automation is the DNA of on-demand platforms. Infrastructure as code and repeatable automation transform manual operations into software. Provisioning, scaling, security configuration, testing, deployment, and recovery become versioned, reviewable artifacts. This reduces human error, increases reproducibility, and shortens feedback loops, so teams can ship and iterate faster. For a platform to be extensible, it must be scriptable and automatable end-to-end. How AWS applied it. AWS invested early in programmatic control, APIs, command line tools, and later managed services that embraced automation patterns. Infrastructure as code tools and templates became first-class patterns for provisioning networks, compute, and storage. Automation enabled scale, environments could be reproduced across accounts and regions, and services could be orchestrated by 100-400 pipelines. 3 mistakes companies make. Mistake 1. Treating automation as an afterthought. Teams often automate only the happy path, or automate operations reactively. When automation is incomplete, manual steps remain brittle and slow. This produces variability across environments and undermines developer confidence. Mistake 2. Building brittle, undocumented scripts. Ad hoc scripts without tests or version control become technical debt. They fail silently, diverge between environments, and are hard to audit or hand over to new team members. Mistake 3. Automating without safety guards. Automated operations that lack safeguards, quota guards, dry run modes, permission boundaries can cause large-scale mistakes. For example, mass deletion or uncontrolled cost growth. Lessons learned. Make automation the default design choice. Treat runbooks as code. Version, test, and review infrastructure definitions the same way you do application code. INCMED guardrails. Dry run modes, staged rollouts, cost limits, and least privilege access. Episode tying to Windows under Microsoft, where Windows-era systems often emphasized shipped installers and manual enterprise deployment procedures. AWS shifted the expectation to repeatable, programmable provisioning. Entrepreneurs should learn both sides. The Windows approach taught the value of carefully controlled upgrades for stability. The AWS approach teaches how reproducible automation enables scale and experimentation without sacrificing reliability. Principle for Design for Fault Tolerance and Observable Systems Explanation. Resilience at scale is a design discipline. Build services assuming failure. Networks partition, instances crash, and dependencies degrade. Combine redundancy, graceful degradation, retry patterns, and circuit breakers with robust observability, metrics, logs, traces, and alerts, so teams can detect, localize, and recover from incidents quickly. Observability is not optional telemetry. It is the medium through which teams learn about real-world behavior and improve the system. How AWS applied it. AWS offered managed services with built-in replication, multi-availability zone deployments, and retriable SDKs. It pushed best practices for idempotent operations, exponential backoff, and health checks. At the same time, AWS emphasized observability primitives, monitoring, distributed tracing, and logging. Tectate made systemic issues diagnosable across services and accounts. 3 mistakes companies make. Mistake 1. Prioritizing feature velocity over resilience. Startups can ship fast without designing for failure, only to discover catastrophic fragility under load or partial outages. Short-term gains from speed can turn into long-term costs in customer trust. Mistake 2. Instrumenting too late or incompletely. Adding monitoring as an afterthought leaves blind spots when incidents occur. Lack of end-to-end request tracing and contextual logs makes root cause analysis slow and expensive. Mistake 3. Treating observability as metrics only. Relying solely on high-level metrics without logs and traces misses the nuance needed to debug complex interactions and long-tail failures. Lessons learned. Design for failure modes from day one. Codify resilience patterns and test them. Chaos experiments. Build comprehensive observability. Correlated metrics, structured logs, and traces with contextual metadata. Make incident practices routine. Run books, run retrospectives, and post-incident learning loops that feed product and architecture decisions. Episode Tying to Windows. Under Microsoft Windows installations historically prioritized compatibility and surface stability across many hardware configurations, but deep observability into distributed enterprise behavior was limited by the Era-S tooling. AWS's emphasis on observable, distributed resiliency shows entrepreneurs how operational visibility becomes a core product attribute when systems are distributed and multi-tenant. Principle 5. Compose managed services and embrace serverless primitives. Explanation. Rather than asking teams to operate every layer, provide managed building blocks that handle undifferentiated heavy lifting, databases, queues, identity, 1005 inference, so builders compose higher-level value. Serverless primitives, event-driven functions, managed databases, and fully managed APIs let teams focus on business logic, while the platform handles scaling and availability. Composition accelerates delivery, reduces ops burden, and encourages experimentation. How AWS applied it. AWS expanded from raw primitives, virtual machines, and object storage to higher-level managed offerings and serverless constructs. Lambda popularized event-driven small functions, managed databases, and fully managed analytics, allowed teams to assemble complex workflows without managing underlying clusters. This composability lowered the cost of building differentiated services. 3 mistakes companies make. Mistake 1. Overusing primitives instead of leveraging managed services. Teams sometimes build and operate their own versions of managed services because they fear lock-in or want fine-grained control. This incurs operational cost and distracts from product differentiation. Mistake 2. Treating managed services as magical black boxes. Relying on managed offerings without understanding performance characteristics, limits, or cost models leads to surprises in scaling and bills. Mistake 3. Composing services without transactional and consistency. Thinking stitching many managed services often creates eventual consistency boundaries and failure modes that require architectural patterns. Idempotency, compensating transactions. Ignoring these leads to subtle correctness bugs. Lessons learned: use managed services where they accelerate time to market. Defer building custom infra until there is a measured, defensible need. Learn the operational and cost constraints of the services you consume. Model them in early load tests. Architect explicitly for distributed composition. Idempotency, retries, and compensation patterns should be part of designs. Episode tying to Windows under Microsoft Windows era, favored shipping rich client functionality, and given APIs for local resources. Many application pains came from each vendor resolving storage, syncing, and identity. AWS's model shows how centralizing those concerns as managed services removes repeated effort and enables many innovators to focus on unique product experiences, a lesson entrepreneurs can apply when choosing what to build versus what to consume. Closing for Part 2. This part covered 3 more principles for ideation, inspired by AWS: automate everything, and enable infrastructure as code, design for fault tolerance and observable systems, and compose managed services while embracing serverless primitives. Each principle included practical guidance, 3 common mistakes, lessons learned, and analogies to the Windows story so entrepreneurs can see how platform era differences change trade-offs. In Part 3, you'll receive the final 3 principles. Principles 6, 7, and 8, plus a practical ideation workshop that translates these principles into exercises, experiment templates, and checklists entrepreneurs can run to generate and validate platform-centric product ideas. If you would like any of the principles reframed for a specific industry, tell me which industry, and I will adapt the examples and exercises. Part 3 Introduction. This final part completes the AWS-inspired ideation narrative with the remaining 3 principles and then translates all 8 principles into a practical, repeatable workshop entrepreneurs can run. The goal is to move from insight to action. Given the platform lessons from AWS and the comparative echoes of the Windows story, how do teams generate, validate, and begin building platform-aware products that scale? This part includes detailed exercises, experiment templates, checklists, and facilitation notes designed for training entrepreneurs and product teams. Principle 6. Design for multi-tenancy, security, and compliance by default. Explanation. At scale, isolation, security, and regulatory compliance are not afterthoughts. Designing multi-tenant systems from the start reduces costly rework and enables service economics that power platform growth. Security by design and compliance by default mean embedding identity, encryption, access controls, and auditability into primitives, not retrofitting them around features. This lowers friction for enterprise adoption and protects the platform's reputation and customers' data. How AWS applied it. AWS built identity and access management, encryption tools, isolation through accounts and VPCs, and compliance certifications into the platform. By making security controls and compliance evidence available to builders, AWS reduced the barrier for enterprises to consume cloud services and for startups to reach regulated markets. 3 mistakes companies make. Mistake 1. Treating security as a checklist item. Teams often bolt on security controls at launch rather than architecting systems with least privilege, secure defaults, and threat modeling. This creates fragile guardrails and rework when scaling. Mistake 2. Hiding compliance behind bespoke services. Custom compliance solutions for each customer increase operational cost and block scale. Lack of standardized controls makes enterprise procurement slow and expensive. Mistake 3. Exposing broad privileges for convenience. Giving wide permissions to accelerate development is expedient but dangerous. Overly permissive defaults create severe blast radii during incidents. Lessons learned: build identity, encryption, and auditability into primitives from day one. Create standardized compliance evidence and repeatable controls to accelerate enterprise adoption. Favor secure defaults and least privilege. Provide well-documented paths for customers to request exceptions with governance. Episode tying to Windows under Microsoft Windows era solved many compatibility and compatibility-related security problems through patching and enterprise controls, but the centralized OS-level control model differed from the Cloud's multi-tenant realities. AWS's design for tenancy and security highlights a shift. Entrepreneurs building platforms today must bake in isolation and compliance to unlock larger enterprise customers without exponential operational burden. Principle 7. Invest in developer experience and community as primary product levers. Explanation: developer experience and community are core product levers for platform adoption. Good 510 reduces time to first success, lowers integration cost, and creates advocates. Community accelerates knowledge sharing, builds trust, and amplifies product reach. Documentation, SDKs, tutorials, reproducible examples, interactive sandboxes, and responsive support are not optional. They are the product interface for builders. How AWS applied it. AWS invested heavily in documentation, code samples, SDKs, across languages, hands-on labs, certifications, events, and a partner network. The company cultivated user communities and third-party training ecosystems that lowered onboarding friction and expanded the platform's technical reach. 3 mistakes companies make. Mistake 1. Underinvesting in documentation and examples. Sparse or inconsistent documentation forces developers to reverse engineer behavior. This lengthens integration time and reduces confidence in the platform. Mistake 2. Treating community as marketing only. Community thrives on technical depth and reciprocity. Viewing it solely as a promotional channel misses its role as a feedback loop and product development amplifier. Mistake 3. Failing to measure developer success. Without tracking developer time to first integration, error rates, and support ticket causes, teams cannot prioritize improvements in the developer journey. Lessons learned. Treat developer experience as a first-class product. Invest in documentation, SDKs, and reproducible examples. Build community infrastructure, forums, events, partner programs, nurture contributors. Instrument and measure developer journeys, then iterate on the highest friction points. Episode tying to Windows under Microsoft Windows created vast application ecosystems through early investments in developer APIs and tools. AWS's emphasis on developer experience extended that lesson into the cloud era. When builders can move quickly and reliably, Platform adoption accelerates. Entrepreneurs should treat Community and 510 as strategic channels, not purely support functions. Principle 8. Experiment continuously and use metrics to evolve product boundaries. Explanation. Platforms must adapt. Continuous experimentation, small releases, feature flags, controlled rollouts, and broad A/B testing, combined with outcome-oriented metrics, enables teams to learn what primitives, pricing, and governance practices drive ecosystem health. Use data not to justify past decisions, but to surface where to tighten interfaces, extend primitives, or shift commercial terms. How AWS applied it. AWS iterated services rapidly, used internal and external pilots, and monitored qualitative and quantitative signals, partner growth, customer cost efficiency, latency and error rates, adoption velocity, to decide which services to expand, deprecate, or evolve. The culture emphasized customer obsession and measurable outcomes. 3 mistakes companies make. Mistake 1. Running experiments without clear success criteria. Experiments that lack defined metrics waste time. Without target outcomes and decision rules, teams debate forever instead of adapting. Mistake 2. Ignoring ecosystem-level metrics. Focusing only on direct product metrics misses systemic signals, partner churn, integration depth, or marketplace dynamics. Determine long-term platform health. Mistake 3. Confusing short-term activation spikes with sustainable product-market fit. Early promotional boosts or tactical incentives can mask weak product fundamentals if not evaluated over longer horizons and cohorts. Lessons learned. Define clear experiments with measurable success thresholds and pre-planned decision rules. Track ecosystem-level metrics. Partner retention, revenue per partner, time to first integration. Correlate them with product changes. Use pilots and staged rollouts to gather both technical and commercial evidence before broad commitments. Episode tying to Windows under Microsoft Windows evolved over decades through an interplay of experimentation and deliberate compatibility choices. The WSS culture institutionalized rapid, data-informed experiments across services. For entrepreneurs, the lesson is to combine the Windows-era discipline of compatibility and long-term commitments with AWS-era experimental rigor to find sustainable platform boundaries. Workshop. Translating principles into practice. Overview. This workshop is designed to be run in a half-day session for a small founding team or a series of shorter modules across multiple sessions for larger groups. The objective is to generate platform-oriented product concepts, validate core assumptions quickly, and prepare a concrete next-step plan for pilot partnerships and experiments. All exercises link back to the 8 principles and use the Windows and AWS narratives as framing metaphors to show trade-offs between stability and speed, compatibility and innovation, and governance and growth. Preparation and materials. A facilitator familiar with platform concepts. A room or virtual space with whiteboard or collaborative board tools. Template decks. Idea canvas. Partner economics canvas. Migration checklist. Governance blueprint. Experiment template. Optional. Sample SDK snippets. Mock DPI docs. And a landing page prototype. Agenda. Half-day session structure. Warm-up and framing. 15 to 20 minutes. Align on user problem and ecosystem actors. Idea generation sprint. 30 minutes. Divergent ideation focused on primitives and composability. Selection and mapping, 20 minutes. Choose top 1 or 2 ideas and map their builder and user journeys. Partner economics and distribution design, 30 minutes. Use the partner canvas to design incentives and go to market. Compatibility and governance planning, 30 minutes. Draft migration and governance outlines. Experiment design and decision rules, 20 to 30 minutes. Define the first experiments and thresholds. Wrap up and next steps, 10 to 15 minutes. Assign owners and timelines. Detailed exercises, warm-up and framing. Ecosystem story mapping. Step 1. Tell the user story in 3 sentences. Who is the user, what pain they encounter, and how they currently work around it. Step 2. List stakeholders, end users, developers, integrators, distribution partners, compliance officers. Step 3. Identify one asset users care about: data, workflow, identity. Hypothesize a primitive that could unlock value if exposed. Idea generation sprint, primitives, and composability, rule set. Generate 30 ideas in 15 minutes. Prioritize breadth over depth. Aim to convert at least one idea into a primitive rather than a feature. For each candidate, capture the primitive name, the primary builders, one-sentence user value, and the simplest way the primitive could be consumed programmatically. Voting. Use .voting to select the top 2 ideas for further development, selection and mapping. End-to-end narrative. For each selected idea, write a short narrative showing an end user adopting a third-party app built on the primitive. Map the developer journey, onboarding, first integration, test deployment, go live. Identify key risks and the minimum outputs needed to validate the hypothesis. Partner economics and distribution design. Partner canvas drill. Fill the partner economics canvas for partner personas: a small independent developer and an enterprise integrator. Design co-marketing moves and initial distribution channels, marketplace listing, pilot integration, pre-installation or bundling if relevant. Define short-term incentives, credits, revenue share, joint customer introductions, compatibility and governance planning. Migration and policy sketch. Use the migration checklist to enumerate critical assets and the commitment level for each. Draft a governance blueprint, listing rules, enforcement model, and first-party policy. Role-play a deprecation scenario. Communicate the timeline and offer migration tools. Experiment design. Quick evidence loops for each top risk. Design an experiment using the experiment template. Partner interest outreach. One-page specs sent to identified partners. Landing page test. Prototype page with sign-up CTA, targeted campaign amplitude limited to a small audience. Concierge pilot. Manual integration delivered for the first customer to validate user value before automating. Define success thresholds and pre-commit decision rules for follow-up actions. Templates and artifacts. Leave the workshop with idea one-pager. Fillable. Primitive name, one-line user value. Target builders and business models. Minimal API surface and example call. First experiment and success threshold. Partner economics canvas. Fillable. Partner persona. Value. Unlocked. Cost to integrate. Platform enablement offered. Commercial model and metrics. Migration checklist. Fillable. Asset inventory. Compatibility commitment level. Migration tooling required. Communication plan. Governance blueprint. Fillable. Participation rules. Enforcement and appeals. Data access policy. First-party product policy. Experiment template. Fillable. Assumption being tested. Experiment design. Sample size and duration. Success threshold. Decision gate. Facilitation notes and common pitfalls. Keep the session time-boxed. Experimentation benefits from constraints. surface assumptions explicitly. Every hypothesis should be testable. Avoid jumping to engineering estimates in ideation. Keep early work focused on validation. Ensure roles are assigned for experiments: owner, outreach lead, technical lead, and measurement owner. Bringing Windows and AWS stories into the workshop. Use the Windows story when discussing compatibility commitments and long-term ecosystem trust. Ask the team, which legacy behaviors would we preserve to reduce partner friction? Use the AWS story when designing metered economics, automation, and managed service composition. Ask, how can we make experimentation cheap and reversible? Create a 2-column trade-off board with one side labeled Windows Era Discipline and the other labeled AWS Era Velocity. During decisions, require the team to state which side they are prioritizing and why. Closing checklist before pilots. Have at least one partner expressed willingness to trial the primitive. Is there a landing page or single-page spec ready to capture developer interest? Are minimal programmatic interfaces and a sandbox environment available for early testing? Is there a migration plan and a clear governance policy communicated to potential partners? Are experiments defined with measurable thresholds and owners assigned? Final reflections. Platforms are long-duration bets built from many small, coordinated choices. The Windows story teaches endurance, compatibility discipline, and ecosystem orchestration. The AWS story teaches elasticity, automation, transparent economics, and composition. Entrepreneurs can blend both legacies. Commit to durable promises that reduce partner risk while embracing experiment-driven velocity to discover product-market fit. Use these principles as lenses, not checklists, to evaluate ideas. Each startup must decide how much to prioritize stability versus speed, how much control to retain versus how much to enable partners, and which primitives are worth exposing as foundational building blocks. Run the workshop, test the riskiest assumptions quickly, and let evidence guide the next phase of platform investment. If you would like, I can convert the workshop templates into editable documents, produce facilitator scripts for a full-day training session, or adapt the exercises to a specific industry such as healthcare, fintech, or industrial I. Which adaptation would you like next?